All right, we are looking at the review for Chapter 5. I'm going to go through this key and try to explain how I got to my answers, and hopefully this will be beneficial to you. So the directions for number 1 is find the degree of the polynomial. So you find the term that has the biggest exponent, which is a 3, and that's the degree. The leading coefficient is the number that you're multiplying by the variable in front of the variable that has the biggest exponent. So in this case, it's a -8. Number 2, we are supposed to simplify. So we have a binomial times a trinomial, and we're subtracting from that a binomial. So we have to use the distributive property and multiply 4 times 4x squared. It gives us 16x squared. 4 times a plus x is a plus 4x. Minus 8x times a minus 7 is a minus 50, is a plus 56x. I guess I got kind of carried away there. Before I do that, let's multiply the 4 times the -7 to get minus 28. The order in which you do this doesn't matter, but you should do it in a logical order so you don't get confused like I just got confused. If I distribute the -8x times 4x squared, I get -32x cubed. -8x times a plus x is a minus 8x squared. And then, this is what I said earlier, minus 8x times a -7, or minus 7, is plus 56x. I distribute this negative here, and I get a minus x. Distribute this, and I get a plus 9x cubed. Then we want to combine like terms. Like terms means same letter, same exponent. So these two red terms are like terms. Put those together. We get minus 23x squared, cubed, that is. We got a 16x squared and a minus 8x squared is going to be a plus 8. When you combine like terms, you combine the coefficients. We have a plus 4x, a plus 56, and a minus 1x. It gives us plus 59x. And minus 28 does not have a like term. Number 3 is supposed to factor. So you want the terms in descending order with respect to the exponents. You like your leading coefficient to be positive. GCF of these two terms is a 3. If I divide 75a squared by 3, I get 25a squared. If I divide 108 by 3, I get 36. We have a minus, we have a minus. Then for this binomial, this is a difference of two squares. 25a squared is a perfect square. 36 is a perfect square. It's a difference. So you take the square root of the first term, 5a, put that in the first spot of each binomial. Make 1 minus and 1 plus. The order doesn't matter. Take the square root of 36, put that in the second spot of each binomial, and it's factored. This next one is a trinomial, 3 terms. First thing you're supposed to do is factor out the GCF. If the GCF is 1, like it is in this case, then you don't do it. Since there are 3 terms, I want to make it so there are 4 terms, so I can factor by grouping. So to split the middle term, minus 37xy into a minus 10xy plus a negative 27xy, I multiply the first term times the last term. 6 times 45 is, 270 maybe? I don't know. I'm not good with numbers. I need to multiply to get 270x squared y squared. Needs to add to get negative 37xy. And I found the two numbers that worked, 2 terms, is a minus 10xy and a minus 27xy. Make sure that the sign between the two middle terms is a plus sign. Then we're going to group together terms with common factors like these two and these two, and then GCF each group. GCF of this is a 2x, put her in front, leaving us with a 3x minus 5y. We get this from dividing each of these terms by 2x. This next group, the signs are in the opposite orders of the signs in the first binomial. So I want to make sure I factor a negative out to get the signs in the appropriate order. GCF of these two terms is then going to be a 9y, or I took out a negative 9y. So you can write minus 9y, or you can put a plus negative 9y. Either way, leaving us with 3x minus 5. The two binomials in green are the same. GCF that out to the front, leaving us with the binomial of 2x minus 9y, which we can see here in red. Number 5, still factoring. It's a trinomial again. Lead coefficient's not 1, so I recommend factoring that out to the front. It's going to change these signs to pluses. If you're fortunate enough that the leading coefficient is a positive 1, you don't have to split the middle term. You can just find two numbers that multiply to get 32 and add to get 12, and you're going to make two binomials then. The square root of the first term goes in the first spot. Square root of x to the fourth is x squared. Two numbers that multiply to get 32 and add to get 12 are a plus 8 and a plus 4. These do not factor anymore. They're both binomials. Binomials can only factor in one of three ways. Difference of two squares, these are sums. Difference of two cubes, these are sums. Sum of two cubes, these are not cubes, so it doesn't factor anymore. Number 6, 7, and 8, solve each equation, give exact answers, and find all solutions, real and imaginary. So my plan when I'm starting out 6 is, I'm hoping that when I get 38x on the other side, by subtracting it, I'm going to be able to factor this. GCF of this is x, so I pull it out to the front. Leave me with x squared plus 4x minus 38. Then, I want to factor this. I need two things that multiply to get negative 38 and add to get 4. There are no integers that do that. So I'm left with little to no choice. I'm going to have to complete the, pardon me, I could complete the square. We haven't talked about that yet. I know you did it with Mr. Paul last year. We're going to use the quadratic formula, which is really completing the square. So notice how we can't forget this GCF. We set it equal to 0. I drew this arrow down here because I don't want to forget it. We take the trinomial that's left and we're going to apply the quadratic formula to it. Quadratic formula is negative b plus or minus the square root. This is called inside here the discriminant. The discriminant to b squared minus 4ac divided by 2a. In this case, a is 1, b is 4, and c is negative 38. So if I fill the numbers in, anytime you substitute, use parentheses. And as I simplify this, 4 squared is 16. A minus times a negative is a positive. 4 times 1 times 38 is 152. If you add 16 and 152 together, you're going to get 168. On the bottom, 2 times 1 is 2. So now we're here. 168 is not a perfect square, but one of its factors is 4 times 42 is 168. Square root of 4 is 2, so I pulled that out to the front. Now at this point, this here is not a bad answer, but we can do better because we can GCF a 2 out of the numerator, like so. So we can cancel a 2 from the top and the bottom, and we're left with negative 2 plus or minus the square root of 42. That's one of our solutions. Well, that's actually two of our solutions. We can't forget the 0 that were brought down, x equals 0. So this has three x-intercepts, 0, negative 2 plus the square root of 42, and negative 2 minus the square root of 42. This next one has lots of terms. We want to get all the terms on the same side of the equation. We're going to subtract 4x squared from both sides, combine it with a like term and get 5x squared. Going to add x to both sides, going to add 5 to both sides. Once all the terms are on the same side, I have 4 terms in this polynomial. So I'm hoping that I can factor by grouping. I'm going to group the first two terms together. I'm going to group the last two terms together. GCF of this first group is an x squared, leaving with x plus 5. GCF of this next group is a 1. You really should write the 1 in front. If you choose not to, I won't count it wrong, but you get into trouble on the very next step because this plus 1 here goes inside with this binomial, and if you don't write the plus 1 here or the GCF, you might forget this. So I would encourage you, if the GCF is 1, to write it in front. Since these binomials x plus 5 are the same, we factor them out to the front, leaving us with x squared plus 1 here. X squared plus 1 does not factor anymore, so we set each factor equal to 0. You're going to get x equals negative 5. Here you're going to get x equals plus or minus I. It is important if you want to receive full credit, that you don't just go from the factored form to the answer. That's cool with Mr. Paul, and I'm cool with that being cool with him. It's not cool with me. So if you want all credit, you need to show all that work. Number 8 is going to be a trinomial again. If we subtract 5x and we add 4x cubed to both sides, we get this hot mess, GCF and x. We luck out, the leading coefficient's a 1. So we're going to make two binomials, the square root of x to the fourth in the first spot of each. Then we need two things that multiply to get negative 5 and add to get positive 4. So a plus 5 and a minus 1 works. Neither of these, well, this x squared plus 5 doesn't factor anymore. X squared minus 1 is the difference of two squares. Factors into an x minus 1 and an x plus 1. Once it's already factored, which it is now, set each factor equal to 0. X equals 0, x squared plus 5 is 0, x minus 1 is 0, x plus 1 is 0. Solving this fella here, we're going to get x equals plus or minus the square root of negative 5. For a negative inside a radical, you can pull an I out of that. Gets rid of the negative. Over here, we add 1 to both sides, we subtract 1, we end up with 4x intercepts. Scratch that, 5x intercepts. 0 plus or minus 1, and then the imaginary plus or minus I square roots of 5. Number 9, use long division to divide 1 plus 4x squared minus 8x squared by 2x plus 2. You need to write these in descending order first of all, which I did here. I was missing a term between x squared and x to the 0. This is x to the 0. So I put a plus 0x in. For the long division to work, you take the first term that you're dividing and divide it by the first term you're dividing by. So if I were to write down 4x cubed divided by 2x, x's cancel. 4 divided by 2 is 2. You end up with 2x squared, which is why this says 2x squared up here. Then I multiply 2x squared times 2x and get 4x cubed. 2x times 2 is a 4x. The way I like to do this is not required. You're supposed to subtract this from the previous two terms. I like to change it to addition and change the signs. You don't want to do that? It's America. Don't do it. 4x cubed plus a negative 4x cubed, 0. Minus 8x squared plus a negative 4x squared minus 12x squared. Bring down the next term. Then I got to figure out how many times 2x goes into a negative 12x squared. That's going to go a minus 6x times. So I multiply negative 6x times 2x is negative 12x squared. Negative 6x times 2 is a minus 12x. I'm choosing to add and change the signs. So then I'm going to a minus 12x squared and a plus 12x squared cancel. 0x plus 12x is 12x. Bring down the 1 from down yonder, actually from up yonder. Then I got to divide 12x by 2x. It goes 6 times. 6 times 2x is 12x. 6 times 2 is 12. I'm choosing to add and change the signs, leaving me with 11 negative as a remainder. Instead of writing it as a remainder, I'm going to write it as a plus whatever remainder is divided by whatever you're dividing by. Long division. Number 10, is x plus 7 a factor of this polynomial? Show any work that leads to your conclusion. You can do this in one of 3 ways. One way is to take and write this in the correct form. The correct form would be x minus a number, so that's x minus a negative 7. Put a negative 7 into the function, showing all of your work, see what it ends up being. If it ends up being 0, it's a factor. Probably not the best way to do this problem because it requires lots of huge calculations. Another way to do this problem is to take this polynomial and divide it using long division and see if you get 0 as a remainder. A third way would be to take the coefficients of this polynomial.
I don't understand. A third way would be
and then divide it synthetically by -7. If that remainder is 0, then it's divisible, or it's a factor of that. So any of those three ways work. It's important that I'm saying why this worked. So it says show any work that leads to your conclusion. I showed work, and then I said, yeah, since f of -7 equals 0, x plus 7 is a factor of this. If you did long division, you would say, since this polynomial divided by x plus 7 has a remainder of 0, then it's a factor. Number 11, use the graph of the function to determine at least one 0. Then find the exact values of all the zeros using the factor theorem. So it looks like, to me, this is crossing at -3, at -1 point something, a little bit to the right of 0, a little bit to the left of 2. You want to choose the x-intercept that's an integer, and it appears that -3 is an integer. And to confirm that, I'll take these coefficients, divide it synthetically by -3, and when I do that, I get a remainder of 0. Just a quick review of how you do synthetic division. I take the coefficients of each of these terms, making sure that if I'm missing any, I put a 0 in. Bring the 7 down, multiply -3 times 7, I get -21. Then I add 20 and -21, I get -1. Then I multiply -3 times -1, and I get +3. Then I add -24 plus 3 is -21. -3 times -21 is 63. I add, and I get 3. -3 times 3 is -9. I add, I get a remainder of 0. So I was correct in looking at this and seeing that this actually crosses at -3. So now I know that the original problem factors into this mess here times x plus 3. I didn't write that down for this. I could. For example, I could leave the work how I had it, or I could have this in parentheses and have a times x plus 3 beside it. And if I were going to do that for this work, I would have this all the way down, this x plus 3. You don't have to. You can if you want. Anyhow, once you have these 4 terms, you want to factor that to try to find solutions. So I chose to factor by grouping. Let me erase this stuff so we can focus on what's here, not what's not there. To factor by grouping, I group the first 2 terms together. I'm going to change this to a plus and group the last 2 terms together, so that little negative there is a -21x to the third. GCF each group. GCF this is x squared, leaving us with 7x minus 1. GCF of this is a -3, leaving us with 7x minus 1. Notice the binomials are the same. Pull it to the front, and then I have an x squared minus 3 as another binomial. Neither factors anymore, set each factor equal to 0. So we end up with an x-intercept of 1/7, a plus or minus square root of 3. You can't forget the original x-intercept that we found from the graph. A common mistake is forgetting that. So this has, well, as you can see in the picture, there's 1, 2, 3, 4 x-intercepts. I have 1, 2, 3, 4 x-intercepts. Yummy. Number 12. List all zeros of this function. Zeros are x-intercepts, roots, solutions. So before I forget, we're given 1 here. We know this 1 is a solution or a 0 because it equals 0. So I make sure I put 1 in my solution. I'm then going to again divide the coefficients x cubed minus 1 by 1 synthetically. Now if you recognize x cubed minus 1 is the difference of 2 cubes, you could factor it that way. We haven't talked much about factoring difference of 2 cubes. I know you did it last year in Algebra 2, and there's a place on my website where you can review how to do that in the review section. But let's say you didn't recognize it, which is fine. and you do synthetic division, you end up with 1, 1, and 1, which is x squared plus x plus 1. This doesn't factor, so we use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Plug the numbers in. We're putting a 1 in for b, we're putting a 1 in for a, we're putting a 1 in for c. They're all 1s. This ends up simplifying to negative 1 plus or minus the square root of negative 3 over 2, a negative square root. You can pull an I out to the front and make it a positive square root. So this is two imaginary solutions that go along with the one real solution that we were given at the beginning. Number 13, 7i minus 6 is a real 0. Pardon me, is a 0. It doesn't say it's real. Couldn't be real, it's imaginary. List another one. So it's asking for the conjugate. The conjugate has the same real number, minus 6, and the opposite sign for the imaginary part, which would be a minus 7i. So it's minus 7i minus 6. 14 is very similar. It's written in a different order. The square root of 17 minus 4i is a 0 of the function. List another. Well, it's going to be the square root of 17 plus 4i. Just asking for the conjugate. 15. Factor the function and sketch the graph. And it reminds you that knowing where the zeros are and what the end behavior is extremely important in this. So the first thing I did is I factor out the GCF, and I also make sure the lead coefficient is positive. So I factor out a negative x, which decreases all the exponents by 1, and it changes the signs of all the terms. Then I group together the first two terms and the last two terms. Notice once again this was a minus 16x, change it to a plus, and make this a negative 16x. GCF of this first group is x squared. GCF of the second group is a negative 16. X plus 4 binomials are the same, leaving us with x squared minus 16. This is a difference of two squares, factored into an x plus 4 and an x minus 4. The end result is we end up with an x-intercept of 0, of negative 4 with an even multiplicity, of positive 4 with an odd multiplicity. So these two, when the graph touches it, it goes through them. Here at negative 4, it's tangent. The graph is tangent to the x-axis. Also, as far as end behavior goes, the leading term is a negative x to the fourth. Negative, it opens down. X to the fourth, the end behavior is the same on the left and the right. If I put all that together, I have an x-intercept of negative 4 with even multiplicity, so it goes up and comes back down. I have an x-intercept of 0, it crosses through. An x-intercept of 4, it crosses through. Notice the end behavior is as I expected it to be. It points down as you go left and right forever. 16 and 17. List the possible number of positive real zeros or negative real zeros. This is Descartes' rule of signs, René Descartes. You want to make sure the terms are in descending order from greatest to least. Count the number of sign changes. There is one sign change, so the possible number of positive real zeros is 1. There's one sign change. To find the possible number of negative sign changes, to find the possible number of negative real zeros, you look at the sign changes by putting a negative into this. So putting a negative x in, and negative x to the 6 is going to be positive. A negative x cubed is negative. A minus 2 times a negative x is a plus 2x. Then this is already simplified, this is already simplified, and so is this. This one needs simplified. Plus 3 times a negative x squared, negative x cubed is a negative 3x cubed. So how many sign changes are there? 1, 2, 3. So the number of possible negative real zeros is 3, or less than that by an even number. So if you subtract 2 from 3, you get 1. However many sign changes there are, you keep subtracting 2 till you get down to 1 or 0, whichever comes first. You'll never get both, one or the other. 17, 1, pardon me, no sign change, 1 sign change, no sign change. There's 1 sign change for the original function, so the possible number of positive real zeros is 1. Put a negative in for the x's to find the possible number of negative real zeros. You're going to get 5x squared, negative 2x cubed, plus 36x minus 9, 1, 2, 3 sign changes. So there's 3 or 1 negative real zero. Number 18. Given the graph, identify the following. Local minimum values. Minimum values are y values. Part B, local maximum values. Those are also y values. So there's minimums here. It looks like it's about 2 point something negative. I'm guessing negative 2.5. If you had, negative 2.2 to negative 2.7, I'm sure that would be fine. There's another minimum here. It looks to me like it's about negative 1.2. You can have some variance in that as well. For the maximums, there's a maximum here. It looks like it's at 0. There's a maximum here. It looks like it was at 1 or maybe a little bit above it. Minimum degree is 5. Here's why it's 5. This is an odd degree, multiplicity of 1 perhaps. This is an odd degree, multiplicity of 1, another odd degree, multiplicity of 1. So 1 plus 1 plus 1 is 3. This is an even multiplicity, so it's at minimum of 2. So 1 plus 2 plus 1 plus 1 is 5. Minimum degree is 5. Another way to look at it, if you draw a horizontal right through here, you can hit this graph 5 times, which means the degree has to be at least 5. D, sign of the leading coefficient, what has to be negative. If the degree is 5, then normally it opens like this. This is the opposite of that, so that must mean the coefficient has to be negative. It has to go down from the left and continue to go down as it goes to infinity. So as you go left, it goes up forever, and right, it goes down forever. E, write out a possible function for the graph. Leave it in factored form. A possible function means we don't know the actual function. It's just a possibility. So for every odd multiplicity, make sure your exponent is an odd number. For every even multiplicity, make sure your exponent is an even number. So we only have one even, which is at 0. So I got x squared. And then I have an x minus a negative 5, which is the same as x plus 5, with a 1 as an exponent. And then I have a 4 here, so I'm going to have an x minus 4. It's also 1 as an exponent. And then I have 6 as an x-intercept, so I have an x minus 6. So what if someone decided to make the exponents here 5, 31, and 51? I can't count it wrong as long as the exponents are the right, even, or odd. I just typically pick the smallest one that I can. So what about the negative in front? Why is that the case? Once again, to have an odd degree and to have it go up as you go left forever and down as you go right, there had to be a negative in front. That's where the negative comes from. (19) Scientists and fishermen often estimate the weight of a fish from its length. Cool. Thanks, science. The data in the table gives the average weight of North American sturgeon. I think that's pronounced sturgeon. I'm not that smart, but don't tell anyone. For certain lengths. Because the weight is associated with volume, which involves 3 dimensions, we might expect that weight would be associated with the cube of its length. So here's length, here's a weight column. Find a cubic model for this data. To do this, you need to go to your calculator, hit the Stat button, then hit Edit List. Put this in for the x's, this in for L1. Then, since it's a cubic, hit stat calculate cubic. Tell the calculator what's in, and then you know what, I misspoke a moment ago, I'm sorry. When you do the calculate, scratch that. Let me start over for part A. When your calculator, you hit stat edit list. There's no X column. This is L1, this is going to be an L2. I said X in L1. That's not true. L1, L2. So when you put that in and you do the calculate by hitting stat calculate cubic, tell it that your X values are in L1, that your Y values are in L2, and tell it to store the equation in Y sub 1, which is under the variables button. It will give you an equation like this. B, use the model. The model is the equation you have up here. To estimate the weight of a sturgeon of length 56 inches. So you can go in your table, hit second table, type in 56 for X and hit enter. You can look at your graph, hit second calculate value and type in 56. Either way, we are going to continue to round the 2 decimal places. I got 632.031 ounces. C, compare the weight of a sturgeon of length 44 inches as given in the table. So 44 inches should be 282. With the weight given by the model. The model, once again, is the equation up here. If you put 44 into this function, once again using second table, or by putting it into second calculate value, I got that it came out to be exactly 282 ounces, I think. It's odd. No, that's not true. That's from the table. I got the model to be 279.42. So comparing them, well, showing the numbers is a direct comparison. The model was only off by a little bit more than 2.5, which is pretty impressive. 20. Sketch freehand a graph of the function that satisfies these conditions. So f of -2 is -4. That's the first thing I would put on is that point. It's non-negotiable, -2, -4. Put a dot there. Notice it's in red. I have it highlighted in red. Maybe I'll use a lightsaber for this next part. Thought I could rotate my lightsaber, but I guess I can't. I'd like to be able to rotate my lightsaber. Anyhow, x minus 5 is a factor. That means 5 is an x-intercept. That's why there's a blue dot there. Has a multiplicity of 7. Since it's a multiplicity of 7, the graph has to go through it. At this point, I don't know if it goes through this way or this way. I just know that it has an odd multiplicity. C, the leading coefficient is positive. If the leading coefficient is positive, that helps, but at this point, I don't know if that means that it starts up and goes down, or if it goes down and comes back up. D, x squared is a factor of f of x. That means that it crosses the x-axis at 0. That's why it's in purple. It's an even multiplicity because it's squared. So you might want to write down a little e beside the purple, a little o beside the blue, because we know of the odd and even part. E, f of x is even. If it's even, we combine that with c. That means that it opens up going left and right, or it opens down going left and right. The end behavior is the same. Since the leading coefficient is positive and it's even, it has to open up as you go left and right. So if I backtrack now, I know there's an x-intercept here. So I'm going to say that it opens like so. Comes up here and it's even, comes back down and back up. It is true, we don't know what this x-intercept is. It doesn't tell us. It also doesn't tell us that there's only 2 x-intercepts, so we have to assume that it has to cross again. If you look at each of these conditions now, you'll see that this graph satisfies all of those. And now for your favorite problem. Listen very carefully. to the best of my knowledge, I am 99% sure there's going to be a problem like 21 on your test tomorrow. Straight up, I'm telling you that. Now that unpleasantness is over, let's talk about it. A rectangular, let's go off lightsaber, let's go little hand. A rectangular container measuring 1 foot by 2 foot by 4 foot is covered with a layer of lead shielding of uniform thickness. So here's the original picture. This is a rectangular container measuring 1 by 2 by 4. Then the second picture here is after it's been layered with a shielding of uniform thickness. It's kind of like putting a box inside of a box. A says find the volume of the lead shielding as a function of the thickness x in the feet of the shielding. So if this original dimension is x, and we add the same length on the left and right of this, let's say we're adding x to both sides because it says x is the thickness, that means this dimension is going to be 2 plus 2x. If its height is 1, and I add x to the top and the bottom, its height is now going to be 1 plus 2x. If this dimension here is 4, and I add x to the back, that's x plus x. Pardon me, that's 4 plus x. If I add x to the front, that's adding another x. Means this is going to be 4 plus 2x. And that's how I have this right here. Find the volume of the lead shielding. So to be clear, this is the rectangular container. This picture is the rectangular container and the shielding. To find the volume of the shielding, V sub s, I have to take the entire volume of this large rectangular prism and subtract the volume of the smaller rectangular prism. What I'm left with is the shielding, which is kind of like a shell with the inside gone. So to do that, I need to take the big volume, which I labeled as volume 1, minus the small volume, volume 2. To find the volume of a rectangular prism, you take the area of the base times the height. Notice I have more than one base, so I'm using subscript variables. So I have area of base 1 times the height 1 minus area of base 2 times height 2. My base was 2 and 2x, 2 plus 2x times 1 plus 2x. Those are the dimensions. Maybe that's not true. The order in which these are written are interchangeable. It doesn't matter. I think this was length and width and this was height. And then for the original container, the dimensions were 4 times 2 times 1. If I combine those, I get 8. And then I get this. I could multiply that out, but that seems like quite the chore. So the directions for this were find the volume. So the best I can do is have this formula. There's no way for me to know what the volume is. Part B. Find the volume of the lead shielding if the thickness of the shielding is 5/100ths of a foot. We defined up here that x is the thickness. So we're going to replace x with 5/100ths of a foot. I put the little fella in here, and I put her in here, and I put her in here. 2 times 5/100ths is 1/10. 2 times 5/100ths is 1/10. 2 times 5/100ths is 1/10. I'm going to get 2.1 plus 1.1 times 4.1. Using a calculator, that product is exactly 9.471. I subtract 8 from it. The volume of the lead shielding is 1.471 cubic feet. Hope the explanation was good enough for you. I hope that you study tonight and hope you do great on your test tomorrow. Thank you.